So next we're going to Charles from Esri, who's going to present on Spacetime and APIs. So over to you, please, Charles.
Thank you. Good morning, everybody. So this is a bit more of a conceptual presentation. I'm just going to share my screen. I'm going to start with Excel. And basically, I would like to make the case for a better, wider understanding of the role of location and spatial relationships in the indexing, organization, and communication between digital twins. So I'm going to start off with Excel. And I do have, if this goes wrong, I do have a pre-prepared thing, but this is some data from the MODIS satellite showing basically the incidence of fire around the world, fire potential for 1 week. It's open source data. I put it into Excel, and we all know we can look at this in different ways, and we can do things like select a field and do some conditional formatting and see different things. We can look at data in a frequency domain and so on. But if we go back to this part, you can see we have location data, latitude and longitude. What I want to do is I'm going to select this data set, and I am going to insert a pivot table. Let's put that pivot table in. And then in this pivot table, I've got latitude. And latitude is basically a measure of how up and downy data is. So let's just take that, and that I'm going to, just going to hide this little window here. I'm going to take that and put it into a row. Longitude is how east and westy things are. So let's take that. I'm just going to reverse that up and down. And then I'm going to add in this field, which is basically a measure of how much vegetation is being burnt or close to burning around the world. And then I'm going to select everything. And I'm going to take this and make it nice and small. And I'm going to take this and make it slightly smaller. And then I'm going to zoom out. Now, what you see is, hopefully you recognize this. We've just taken this data, this flat data, and we've organized it by its location. And suddenly a very different picture emerges. We can see the context of that data, not just the frequency, but how things relate to each other. So let's take this data and make it all black. And then let's do some conditional formatting against it. So I'm going to go to some more rules. I have a 3-color scale. Let's go for the percentile, make that a nice deep blue. Let's make the midpoint a nice flaming red. And the top percentile, let's make that a nice emergency yellow. And here we have a thematic map showing us the relationship between the data in a way that we couldn't see before. Before, it was just a table of information. I'm impressed I got that right first time. So how does this apply to digital twins? Let's just hop across to here. This is Edinburgh. I live up in Edinburgh. Our old office was here. And I'm just going to change the base map and make it a bit clearer. Let's go for this base map. What I have here is I have got an electrical network. So it's a dummy network, but it is based on a proper digital twin model. So this network understands electrical voltages, transmission, capacitive losses, and so on. And I can ask questions of that via an API. I can say, if I add a new cable here, what load can it support, and so on, questions like that. But this is a center of a city, and in this city, there's lots of things that we need to be aware of if we're going to lay new cables to service like new solar potential or whatever. And if I take my mouse and I move it around, you can see some things on screen. Let's zoom in. There's some gray lines here moving. These lines are the distance to some tree preservation orders. So when I get in closer, I can see that they're here. So I'm moving my mouse here. And every time I move this mouse, I'm taking a location, a latitude and longitude, and I'm asking questions of a system, of an API. And that question is, in this case, how close am I to you? And I get an answer. I get an answer back that says, you're close to an oak tree, and here is the extent you need to worry about that oak tree. If I move my mouse around, I can see a different system that is, there's a set of listed buildings maintained by Historic Scotland that I've got constraints on them about what development I can do around them. If I just move down here a little bit, I can see these are old abandoned gas mains. Now, this is a system maintained by Scottish Gas, and it has a digital twin of where gas mains are and how they operate. These ones happen to be abandoned. But just by moving my mouse around and transmitting my location, I am indexing and knitting together a series of data sets, digital twins, sets of information from multiple organizations: Scottish Gas, Scottish Natural Power, I can't remember the name, areas of special scientific interest. I'm building up some contextual information. Every time I move my mouse, I'm asking a question to say, tell me what is of interest in this area at this point in time. If I then decide I want to actually go and start designing a new electrical cable I'm going to create, first thing is I've asked the twin of the electrical network, where can I validly connect this type of cable? And it shows me where I can connect. And then I start drawing with this cable. And what you can see up here is I'm getting material cost, I'm getting construction cost. This construction cost is calculated by asking Edinburgh City Council to tell me the reinstatement categories of the roads in this area and how much it would cost to dig up and replace that surface as I draw the line. And I'm also getting a constraint report telling me that there is contaminated land here, listed building here, an ancient forest over here, there are abandoned gas mains. So I'm getting like a site or situation report or a design report by the simple act of sketching a line. So what I have actually done with this line is I've communicated a question of, I'm interested in doing something in this area. What do I need to know about? And these various systems, these various digital twins, these various data sets hosted by multiple organizations are communicating to me, and they're using the spatial relationships to create those links and to index that data and provide me with a better contextual view of what I'm trying to do and the various constraints. Now, the way this works, this is my only slide, it's a very blank slide. I have a data set. There's a detailed map that I sketched out showing a clean water network. I have another data set, it's electrical distribution network with its asset data in it. And in this case, I'm interested in where they intersect, because if I want to do work on a major cable, I need to be aware of where the water pipes are. So I'm interested in a spatial relationship called intersection. What that does is it creates a cross-reference table for me. Now, this table is just a list of matching IDs, which is generated by assessing the relative locations of these two digital twins. And this table will get populated. If I add a new cable in here, then a new record will appear in this cross-reference. This isn't about mapping, this is about relationships. So I've defined a location-based relationship, assessed it, and created a table that can be queried behind an API that people can ask questions of, saying, what affects this? We can take this further. So imagine I want to think about future flooding. So next year, there might be a flood, a large storm, and this is the area that'll be affected. What I get is I get another cross-reference table saying, if this floods at this point, here is the information that you need to be aware of. These are the assets at risk of flooding. This orange table is created on the fly by simply sketching in a flood area. But it's an actual table that can be queried by multiple systems. They don't need to be spatial. They don't need to understand shapes. We're just using the relative spatial locations to create information sets that then can be queried. Basically, we're using geography as a way of indexing all of the various systems in the UK that need to talk to each other. We understand where things are. We understand when they're happening, whether that's the future or the past. And we have these APIs where we can ask questions, because as an electrical engineer, I don't understand water. I don't want a list of your data back. What I want to know is, if I do this thing here, what do I need to be aware of from your system? And what do you need to be aware of in your system? And I use APIs for communicating that stuff. So in the interest of time, I'm just going to leave it there. It's basically, I think there's a better, stronger role for a better, stronger case for an understanding of geography and how it can be used to create an index for the UK to help communicate information between disparate systems in a way which is relatively lightweight, very flexible and fluid, and very, very powerful. Thank you.
Very good, thank you. A very visual Gemini call today.